You guys have a great opportunity on Monday because there's a total solar eclipse coming, and you guys are right in the path of totality. And today we're gonna talk about how to view it safely, what an eclipse is. We're gonna do some kind of fun stuff along the way. I want to give you a little bit of my background. I've been a science nerd for a long time. About 3 years ago, there was a partial solar eclipse right here in Liberty, and these are my kids watching that solar eclipse. We went out, we viewed it safely and looked at it, and then this is what we actually saw that day. And what you guys are gonna see Monday is so much cooler than this, because the sun will be completely blocked out. It's absolutely gonna be incredible. What I do at the museum now is I host a TV show for you guys, for middle school students, called STEM in 30. And we do some really cool stuff, and I wanna give you just a little bit of a preview of the season that's coming up. So check this out. Maybe. I could act it.
I could recite it at this point.
So I'm gonna go ahead, while we're waiting on this, I'm gonna go ahead and introduce my special guest today. This is Shauna Edson. Shauna is a science nerd and an astronomy educator at the museum. Give her a big round of applause.
Thank you, Maddie.
Now, Shauna's gonna talk here in a minute. We'll get back to that preview here in a second, but I do need a couple of volunteers. Now, I would love to choose all 809 of you to be volunteers for me, but I'm gonna choose a couple other people. Is there a Mr. Willett around? Oh, I would like Mr. Willett to come down for a second, and I think I'm gonna draft Mrs. Mullen as well. So give them a big round of applause, and we will be back in just a second.
You guys are gonna love this, trust me. So like he said, I am a super proud science nerd. I have been super into science since I was really little. And now I get paid to nerd out about stuff with people. At the Air and Space Museum, I help run the observatory. We have a public observatory with telescopes that anybody can come use. So I get to teach people about space and astronomy, and it's awesome. And after all the years I spent in a desk job, this is so much better. So I heard some people talking earlier today about the eclipse. So there's a lot of information floating around about this eclipse. We've known about it for a while. And one of the things I want to do today is it'll probably verify some of the stuff you already know, but I want to add to that, and I want to clarify some things that have maybe not been presented as well as they could have in the media. Oh, okay, we've got a picture. That's good. Step. So what is an eclipse? Well, eclipse means that something in the sky is being blocked or darkened. This one that's happening on Monday is a total solar eclipse. You know the word solar, solar power, solar system, means it has to do with the sun. So in a total solar eclipse, the moon, which goes around the Earth, on the Earth we've got the moon going around. If you guys are the sun, every so often, the moon is going to come between the Earth and the sun. Now this does not happen every month because the moon's orbit is tilted, so sometimes it's a little too low, sometimes it's a little too high, but a couple times per year, every year, the moon lines up exactly between us and the sun. And depending on where you are on the Earth, if you're in the right spot on the Earth, they will be perfectly lined up, and the moon will exactly block the sun and make it look like that. You guys are incredibly lucky living where you do, because the area where you can see the total eclipse, where it's actually perfectly lined up, is about 70 miles wide. And it goes over this area. There are literally millions of people traveling thousands of miles to come see this total solar eclipse. Because like I said, they happen a couple times every year, but it's just chance which part of the Earth is facing the sun when it happens. The last time there was a total solar eclipse that crossed the United States coast to coast was 99 years ago. For context, the Red Sox and the Cubs were in the World Series together. It's been a while. I'm gonna skip through here. Nope. All right, so this is how far back my science nerddom goes. This is me at age 6 in my Sally Ride flight suit. Yeah, it goes way back. This is me rolling a spacesuit to the White House, like you do. But yeah, so this is the basics of an eclipse, and rather than try and show you a diagram, we're gonna show you in real life, and you guys are actually gonna help.
We're gonna back up a second and show the preview commercial, and then we're gonna do this.
Breaking my flow.
I know. So, everybody can look over here. This is a preview for this season of STEM in 30.
Here's what's happening this season on STEM in 30. We hit the road and take you to the center of the action of the Great American Eclipse.
Discovering discovery. Get a very special look at a very special spacecraft.
The Apollo 11 command module is going out on a nationwide tour. Learn all about the Apollo Moon program. What roles do music and the arts play in space travel? Learn about the psychology of long-term space flight.
Next stop, Mars. Meet Orion, the space capsule that could be flying to the red planet.
Speaking of flying, we learn about the airplane's family tree.
Then we take a highway to the danger zone to check out what happens on an aircraft carrier. Also on STEM in 30, we'll show you how to train to become an astronaut.
We'll also learn about the science of staying safe
And the engineering behind the world record skydive.
and you get to learn how scientists and you can explore the universe. That's all this season on STEM in 30.
If you can't tell, I really love my job. The video of the F-18 taking off of the aircraft carrier, I actually shot that video. So we've got a great season coming up. Hopefully you guys will tune in to watch. And our first show is Monday, and it's going live from right here. So we are really excited to be working with you guys on Monday, and there will be more details about that later. But now we want to talk about what an eclipse is, and so I'm going to bring out the star of our show, a glowing ball of hot gas, at least that's what his students say, Mr. Willett. Give him a big round of applause. All right, so Mr. Willett, come on over here. And our next person is out of this world, our moon, Mrs. Mullen. Come on over. Give her a big round of applause. But now this is where I need all of your help. We are going to create an eclipse right here in the gym, and we are going to have the shadow pass all the way across the gym. So here's what's going to happen. When the moon passes between you and the sun, we want you to clap. Now this is not a golf tournament, so we want clapping, okay? But, no, not yet. Only when the moon passes between you and the sun to create that eclipse. So what should happen is we should have, you guys will start clapping, and then you'll stop once you see the sun again. And then you guys will clap, and then you guys, and we will see that shadow, we will hear that shadow go all the way across the gym. Are we ready? All right, Mrs. Mullen, go ahead and start that path across. Wait till the sun is blocked. There we go. Good job. Good. Outstanding. You guys just created an eclipse, and what's really cool from up here is we heard that clapping go from over here across the gym. And on Monday, that clapping represents the shadow that's going to be passing all the way across the United States. And when it gets here, we will have 2 minutes where we will not be able to see the sun. Let's give our sun and our moon a huge round of applause.
So what we just did, we just made a model. We did a living, moving model of an eclipse. And it takes 3 things to make an eclipse. So we had our sun, we had a moon, you guys were the earth. So you just saw what an eclipse looks like from the Earth's perspective, and the clapping was the moon's shadow. Shadows, when something blocks light, so I'm making a shadow because that light's getting blocked by me. The moon creates a shadow that goes into space, and when it passes over the Earth, if you were in the path of it, you get to see some really cool stuff. I'm gonna skip that video for a second. So this is a view from space of what's going on. So we are in space, the sun's behind us, this is the moon, and the Earth is past that. This is the moon's shadow. Where you see that little black dot, that is where totality is happening. That is where the sun is totally blocked by the moon. So it's tracing its way across the country, and anywhere that it falls for that brief moment, it's moving pretty fast. It moves about 1,500 miles an hour across the surface of the Earth. But for that moment when you are inside the moon's shadow, the sun is totally blocked.
Now, Shauna, that moved really fast. Could we look a little bit closer at exactly where that path is?
You can. So this is the map that a lot of you have probably seen online. But what you just saw in the animation, that's what this is representing. So this is where the moon's shadow is going to go. This is the path of totality. So this little 70-mile wide strip, there's a whole lot of people traveling to that, especially tomorrow and Sunday. The roads are going to be interesting. But we are basically right here. So we are in this really lucky place where we're going to get to see this. And I keep talking about totality. I have volunteers who are amateur astronomers. One is an eclipse chaser. This will be his 5th total eclipse. Everyone who has ever seen a total eclipse tells me it is life-changingly amazing, that it's the most incredible natural phenomenon you will ever see.
Now, I have 2 stories to tell real quick. One, when I went to high school here in Liberty a long, long time ago, I thought I had seen a total solar eclipse. And when I got to the museum, I was like, yeah, I've seen totality before. And immediately Shauna goes, no, you haven't. And I was like, yeah, I have. And she goes, were you in the United States? I said, yeah. She goes, no, you haven't. And I saw a 99.8, and it was really cool. But from what I understand, it is nothing like what we're going to see Monday. When I had told Shauna that we were coming to Kansas City, she started doing calculations on how much totality we were going to have. And I said Kansas City, because it's easier to say for somebody that's not from around here, we're going to Kansas City, not Liberty. So she did the calculations, and she calculated that we're going to get 1 minute of totality in Kansas City, which is true. But we're in Liberty, and Liberty gets 2 minutes. Now, you wouldn't think a minute to 2 minutes. I get an email from Shauna about a month ago. Oh my goodness, I was wrong. We don't get a minute.
As you saw in the model that we made today, the moon's going to move across, and it takes a while. The whole eclipse, from start to finish, takes about 3 hours. And from here, I think it's about 12:30 it's 11:30 to 2:30-ish here. That 2 minutes of totality in the middle is really quick, but it's going to start, so I keep saying totality, so this is the total phase of the eclipse when the sun's totally blocked. Before and after that is the partial phase when the sun is only partially blocked. And so you're going to start off with the sun, the moon starts to come in. I've always thought of this as a cookie with a bite out of it, and the bite just keeps getting bigger over the course of a couple hours. So you get partial eclipse here, you get our 2 minutes of totality, the moon keeps moving, and it goes here. Now, what's really cool, this is something I only figured out maybe a month ago, and it blew my mind. As we're sitting here watching the sun, and especially if you've got your glasses and you're checking the sun every like 15 minutes or so, the moon moving as it passes in front of the sun, the motion that we're seeing, so we're used to the sun and the moon kind of rising in the east, moving through the sky, setting in the west. That's the motion of a day. We're used to that. But with the sun in the sky as a reference point, when the moon goes in front of it, the motion of the moon relative to the sun, what we are seeing in basically real time is the moon moving around the Earth in its orbit. That's what we're seeing. The moon is moving a kilometer a second. That's 2,290 miles per hour through space. And for a moment, with the sun behind it, we can actually see that. And that's nuts.
And that's the only time that you're ever able to really see that. The other thing we want to point out is that with this diagram, you need to be using
It's going to kind of slide over it, see less and less of the sun. Ooh, totality! Oh, it's over. It'll be a little longer than that. Although everybody says it feels like about 8 seconds.
The first time I saw this, I was surprised because I didn't expect the moon to come through it at the angle that it did. Now, one of the things that we've been doing today, we've been showing you guys a lot of diagrams of
All right, looking good.
All right, now,
You've got your arms out there. We want you to imagine that the length of your arms is the distance across the sun. Okay, so this is what's the distance of the sun. How many Earth, and go ahead.
If your wingspan is the size of the sun, the Earth would be the size of your thumbnail. That's how much smaller we are.
So your thumbnail would be Earth, your arm span is the distance across the sun. How many Earths do you think it takes to go all the way across? I heard 200, 10,000, I heard 1,000,000. Sean, how many? Okay, here. All right, Sean, how many does it actually take?
From one side of the sun to the other, you can line up 109 Earths.
Now, I heard 1,000,000, and that's a good guess for a different question.
So in diameter, it's 109 Earths. If you were to open up the sun and fill it with Earths, you could fit 1.2 million. Yeah, you guys can sit back down. So that's your scale. The sun is 109 times the size of the Earth. But the moon is 1/4 the size of the Earth. So how is it that something that is 1/4 the size of the Earth can block something that is 109 times the size of the Earth?
It's because it's so much closer. I think we'll skip.
Exactly.
Yeah, it's so much closer. Now,
It's the exact right distance to perfectly block the sun, which is pretty cool.
all right, so on Monday, you guys are going to have an opportunity to view this eclipse, and there are several ways that you can view the eclipse safely, and we want to make sure that we go over several different ways that you can do this. So, Shauna, what's a way that we can look at it?
Well, I do want to make sure we go back and hit the major safety warning, because I think that's fun.
Yes.
So we're going to skip back through a whole bunch of video stuff to the thing that we skipped at the beginning. So this is why you don't look at an eclipse or at the sun through a telescope that is not designed for it. Now, how many of you ever played with like a magnifying glass with the sun? Like burn dance and stuff? Excellent, got some experimenters. All right, so a telescope does the same thing. Takes a lot of sunlight, concentrates it down to a single point. Use the tech genius. I got this, I'm not playing it yet intentionally, relax. No, it's all good. So at our observatory, we actually pointed our telescope to the sun, and we held some stuff in front of the eyepiece to show you what would happen. So this is why we don't do this to our eyes. This is my little observatory, there's my big telescope. We're using the little scope on the side here. So this is a piece of construction paper. We're moving the roof so that the sun falls on the telescope. That's flame, that took less than a second. All right, now we have a grape that's here in a little cradle.
It didn't cry, it just let out a little whine.
That smoke? That's a black crater that was burned into that grape, again, under a second. Now there's a marshmallow. Yeah. So does everybody understand why you never look into a telescope pointed at the sun without a filter? Excellent, all right. Yeah, that was pretty fun. And Marty, I think the bell there was saying your joke was too bad for them to hear.
I think so. So this is one way that you guys can view the eclipse, and I think your teachers are going to be working
that light shines through, you give it some space. So this person's holding the pegboard kind of up here, the eclipse sun is shining through it, through all the little holes, and it's projecting onto a piece of board. Each of those little holes, this is an amazing thing, it's not projecting the circular shape of the hole. It is projecting the shape of the light source. I tested this with a little LED flashlight that's got 3 little light things in it, and you shine that over like an index card with a hole in it onto the ground, you get 3 little dots of light. You don't get the shape of the hole. It's really cool. So in this one, each of the little holes here, what shape is projecting through there? It's a crescent. It's the eclipse. Exactly. So this is the easiest and safest way to see the eclipse because you're not looking into the sky toward the sun. You're looking at the surface it's projecting onto.
And if you look at the other picture, you'll see that somebody has just interlaced their hands and created holes that the sun's projecting through. But what I think is really cool about this picture, if you look at the trees around them, they created holes, and you actually see the eclipse coming through the leaves of the trees. So you don't even need anything. You can just stand underneath a tree and be able to see the eclipse projected on the ground.
And especially if you want to kind of track the motion of the sun, or the motion of the moon, you can project on a piece of paper, trace it like every 15 minutes, and see how the shape changes. Now, everybody's favorite way to see the eclipse is the eclipse glasses. You've probably seen all the hoopla online about like the fakes on Amazon and the recalls and everything. We're giving you glasses that we know are safe. Marty is demonstrating because he's so cool. Marty, can you see anything through those glasses?
No, like, I'm looking up at the lights and I see nothing.
Makes it safe for your eyes. These are not regular sunglasses. Regular sunglasses are not designed to look at the sun, they are designed to protect you from reflected glare. With these glasses, you can look directly at the sun. And you can do this any day. It doesn't have to be an eclipse day. You can look for sunspots, you can see clouds, you can look for airplane shadows in front, look for Superman. But these glasses will let you look at the sun safely. So during the partial phases of the eclipse, before and after totality, when any of the sun is showing, you wear these glasses, you can see what's going on.
And on Monday, you will all be getting a pair of glasses to go out and view the eclipse safely. Now, Shauna, should we practice a little bit? All right, so we're going to practice what it's going to look like on Monday. So what we're going to do is, we're going to pass out imaginary solar viewers to you guys right now. So everybody catch these. There you go, kid in the back missed it, man. All right, so you guys all have imaginary solar viewers. So what we'd like you to do right now is put your solar viewers up to your eyes. Everybody, teachers too, put them up.
I made us a fake eclipse here.
This is how you have to look at the sun the whole time except for totality. So we've got our solar viewers on. This is how we'll be looking most of the time on Monday. When we get to totality on Monday, you will hear us yell, totality, take off your glasses. So that's what we're going to practice. When the sun comes out of totality, then we put the glasses back on.
The moment you start to see a little bit of brightness, the glasses go back on. That's what we're going to practice, all
All
right?
right, glasses on, here we go. We're getting close, leave them on, leave them on. Not there yet. Almost, not yet, leave them on, leave them on. And totality, take them off, look at the eclipse. You can see stars. All right, now be ready to put them back, put them back, put them back, put them back. Nice. Nice. Are you good?
Amazing reaction time. Those glasses are right back on. Now, did you guys notice that what happened during totality? What did you see? There were stars. During those 2 minutes of totality, this is why my volunteer goes crazy about eclipses and travels thousands of miles. During totality, there were stars. There will be stars visible. On Monday, there will be a really bright star above and left of the sun. That's Regulus from the constellation Leo. There will be 4 planets. 2 of them off to the left, 2 of them off to the right. It'll be Jupiter, Mercury, Mars, Venus. I saw Venus this morning next to the moon. But all of that's going to be visible. The sky gets dark. Crickets start singing. Birds start getting kind of confused and going to sleep. It happens. Animals do. You're really confused. You're like, wait, I thought it was the middle of the day.
So on Monday, don't just look at the sun during totality. Kind of look around and take everything in. Because this is something that
See the corona during an eclipse. There's a whole lot of scientists that are going to be making measurements of it because there's still, even with all our telescopes, there's still things we can only see during an eclipse.
you guys are going to see a lot of information over the next few days about the eclipse. Make sure that you're excited about this because this is a big, big deal. You can view it safely, and I would say now you guys are ready to view the eclipse safely on Monday. So thank you all very much. Enjoy the eclipse Monday. We're looking forward to being back here on Monday.
Let's give our guests one more Eagle round of applause. Awesome. Okay, EAG? Okay, we are going to make sure